one, and then go.
All right, welcome to the Birmingham JavaScript Meetup group. Thank you all for attending. We do have a big crowd. Thanks everybody for coming out. Cheer for yourselves. All right, so I'm going to turn this over to Owen to thank our sponsors and introduce us a little bit.
Yeah, so this is our fifth meetup now. We're growing every week. I want to really thank our host, iTac Solutions, for graciously, letting us use their space and give us beer and pizza. So it's always nice.
Good job, iTac.
Whiteboard for helping with a lot of the logistics and getting a sponsor. Getting our speaker. And also want to thank Command Alcon and Pixis for helping financially support this. It's, you guys helping us out really, shows interest in technology in Birmingham, and we're really grateful for it. So with that, I'd like to hand it over to our speaker, Kris Kowal.
Good job, man.
Yeah, and I have my share of things as well. Thank you to Nathan for inviting me to come here. I've known Nathan since about 2009 when server-side JavaScript was just beginning to kick off. And he was active in the discussions about the module system we were going to use, and has been a proponent of promises. I'm sure you've heard since I started the project to bring promises to Node. This is, I'm calling this a protracted descent into madness because, for one, it's a fun title, but mostly this is going to be a little bit of a different format than normal. I wanted to do something a little risky, so this will be sort of a workshop, sort of a talk. There will be random opportunities to embark in challenges if you brought a computer to fiddle around with Node and see it working on your own machine. Otherwise, I've made far more slides than I have time to present. So I'm just going to keep talking until you all disappear or security hauls me off. That's my plan. There will be plenty of breaks where you can politely excuse yourself. That's my goal, so that it's not awkward. There's going to be a theme that should emerge from this, and the two concepts that I care about the most are modularity and composability, at least for the sake of this talk. There are a lot of other great things to care about, like performance and robustness, securability. I'm going to focus on modularity and composability. You'll note that in composability and modularity are about having interfaces that match in ways that you can stack them. So you'll probably see things where there will be something like the stud on a Lego that matches the anti-stud on another Lego, and then you can recursively build anything you want from them. And first and foremost is the idea of a promise. So what is a promise? Does anybody here already is versed in promises? So you guys have heard a little bit about them, probably used them. Anyone with some experience? Cool. It's been a struggle for me to use promises and to find ways to explain their value succinctly. So this is the latest iteration in a talk to help people understand what promises are, and then to eventually get us into some crazier topics that promises can that you can build on top of promises. A promise is an object that represents the eventual return value or thrown exception from some work. And it does this in an asynchronous way. And the idea behind a promise is to preserve all of the ideas and powerful tools that we use for synchronous code and make them accessible with a little bit of work for asynchronous code. So one of the nice things that we love about writing synchronous code is exception propagation. You do not have to write a try-catch in every place, in every stack frame that an exception might pass through. And likewise with promises, you do not have to catch an asynchronous exception in all of the places where one might occur. They just propagate down to the people who are depending on that work to finish. So this is an example of a synchronous program in Node that reads a file and then parses it as JSON and then returns that. So we are using Node's built-in file system module. We're synchronously reading that file. And this function call blocks until it's finished. So nothing else in JavaScript can happen while this is happening. So there's no chance of interference with other parts of your program. And then when it's finished, the program will proceed. You have the text, then you will parse the text. There's a chance that JSON.parse is going to throw an exception. You'll notice that nothing special is being done about that case. It's up to whoever's calling this function to handle both exceptions because the file wasn't available, because you don't have enough file descriptors to open the file, because the JSON wasn't parsable. All of these cases are invisible in this program. It's ignored, and it's up to your user to catch any of those cases. Now, ideally, an asynchronous program would look almost exactly the same. And the important thing that you need to have in an asynchronous program is it should look the same, but it should explicitly annotate where other parts of your program are going to have an opportunity to run. Because when other parts of your program have an opportunity to run, they have an opportunity to interfere with your plan. For example, if you set up some variables and you've got a callback and you pass that callback to somebody who does whatever they want with it, whenever they want with it, but promises not to do anything with it until a future event, you are expecting that callback not to have been called. You proceed with the assumption that nothing's going to change during your event. With an asynchronous program, you need to have a way to explicitly note in your program where other people will have an opportunity to interfere with yours. In this case, necessarily, that would be between reading and having the text, and between calling this function and when you have a result from this function. So this, after many eons of me talking up here, will make sense. This is an asynchronous program that looks almost exactly the same as a synchronous program, except that it has this q.async decorator around the function, which notes that this is an asynchronous function. It's going to proceed asynchronously, and when you call it, your other programs are going to have an opportunity. Other parts of the program are going to have an opportunity to run. And then furthermore, I'm using a function generator which does not yet exist in any JavaScript environment that you really have access today to, but will very soon. It has a yield statement, or a yield expression, which is a marker that says that when this program's running, I'm going to pause here, allow other things to happen until the file has been read, and then it will proceed when it has the text. But even if you didn't have generators, which are a really powerful concept, but don't exist anywhere that we have access to today, you still get some niceties with promises above what you would have with just plain callbacks. For example, you have implicit error propagation and a few other things. This is a program that you can do today in Node that is equivalent to the first, and it's using a promise. fs.read returns a promise. More things have an opportunity to happen, and when that promise has been fulfilled with the text of the file of the given path, it proceeds to parse that. And if JSON.parse happens to throw an exception, what you're going to get is an asynchronous exception in the resulting promise, and I'll explain how all of that works. This is the behaviorally equivalent program written in Node using only callbacks. And it's important. There are a lot of important details about this that are easy to miss. For one, we're having to pass callbacks, yes. But the most subtle thing about this particular program is that the node back, the last line of significant code, must occur outside of the try catch, because the node back might synchronously throw an exception, and if it did, you would be taking that error and then passing it back to the node back, and you could end up with an error loop. So fraught with peril might be the right way to describe working with raw callbacks. So if you guys have computers with you, let's take our first little break. This one is this is just to get set up and write your first program that uses promises. Make sure that you have Node and npm installed on whatever, and that's just at npmjs.org. Really easy to get a copy of for any platform. You need to make a project directory and move into it. You need to create an empty package JSON, which is just a description of the dependencies that Node's depending on. And then install Q and save that. This will, the -- save is really useful. It adds the information about the dependency to package JSON. So if you were to push this to your source control repository and then download it from somewhere else, you just have to type npm install and get all of your dependencies reinstalled. And then edit your index.js in your favorite editor. This is a simple, this is a trivial joke toy program that constructs a promise for the string hello world that is already fulfilled with the value hello world, and then logs it to the console, and it's done. I presume that in the time it took me to explain, you guys are, anybody still need to see the slide?
Can we announce the Wi-Fi pass?
Wi-Fi password?
What's that?
Greener grass, all lowercase. It is not the guest network, it's the Abstract Solutions Network.
For those of you without computers, do you have instead questions?
What was the star annotation in front of the function?
That's
the function star, or what was that?
No, it's a new kind of function that's coming in the next version of JavaScript, and I'll talk more about that.
Okay, I'll save it.
Yeah. It's what marks the function as a generator function.
Okay.
If you download the newest version of Node in the unstable branch 0.11.8, I'll show you how to use them today. Okay, so moving along, what is a promise? I keep on coming back to this because a promise is many things, and you can define it in a lot of different ways. This is a more general definition of a promise. A promise is a proxy for a value that will, for a result, not necessarily a value, a result that is displaced out of time or space. And the distinction is important because the idea is that a promise can represent any value in JavaScript. It's just a value in JavaScript that you do not have available either in your process or in your process at the moment, or maybe you had it already and you're just waiting for it and you just need to make sure that it's available. It can be from the past, it can be from the future, it can be in another machine. So the most simple implementation of a promise, if you strip that all back, could be implemented with a single method then, and all of its useful behavior could be captured by this single method then. And I like to think about promises as this proxy object that you're sending messages to, instead of thinking about it as a value. The idea is that since you do not have access to this value right now, instead of talking directly with it by using dot and calling member functions, or using or just waiting for it to be available in the next line because it's implicitly available, you send messages to it, and it harkens back to the small talk style message passing, except that this is strictly asynchronous. So you send an asynchronous message. You do not are guaranteed not to have a response in the same event you're working in. And the most basic message you can send is, I need your value here whenever it's available. And that is what a then message is. You pass with your then message a callback, which is a function that will receive the value when it becomes available, and optionally also an errorback, which is a function that will receive an error if it becomes provably impossible to receive it. Now, you're not guaranteed to receive a response, which is where timeouts and such like that come in handy. Which is, if you're doing anything asynchronous, and if you're doing anything asynchronous on a network, you are never guaranteed a response, and you always have to handle the case where the remote is partitioned and no longer available in some appropriate way for your application. So if you're thinking about this in terms of the message passing metaphor, a promise, there's a particular kind of promise, a deferred promise. This is a promise for a value that isn't available yet, or wasn't available at some point in time and has become available since. And the best way to represent, one of the best ways to represent this is with a railroad switch. Carts with then messages are going to come in and they're going to stop at the switch until some resolution for that the deferred promise happens and it becomes a settled promise. When it's settled, it either goes into the fulfilled state or the rejected state. In your cart, the semaphore will open, the switch will switch to the direction the tracks will have been laid, and the cart will move on to its next state. And importantly, if it finds itself in the fulfilled state with a particular value, there's a value associated with the end of each of these tracks. If it ends up in the fulfilled state, whoever's operating the fulfilled state is going to take the callback side of the promise out, call it with the value in a separate event, and there you go. You can proceed from there. If it becomes provably impossible to resolve this, for example, because the connection was closed, or the file is gone, or the disk is on fire, or Earth, well, any of those cases, you will get to the rejected handler. If Earth explodes, you're not going to get a message, I'm sorry. But any of those others, you get to the rejected case. And in the rejected case, it's going the handler at the rejected terminal is going to take out the errorback and call it with the error, and then you can proceed from there. So this is a program that will create a deferred promise manually. You will almost never have to do this unless you're working with something that only works with callbacks and you need to move it into the promise world. This is like moving from one number plane into a different number plane, or moving from callbacks into promises. The way it works is that you call deferred. Q.defer doesn't return a promise. It returns an object that it's a deferred, that has two properties, one of which is the resolver side, and the other is the promise. It's important that these are separate because if promises were designed originally for robust, composable, secure programs, where programs that do not trust each other are running in the same process. So it is possible with promises to take the resolver side and the promise side and give them to different people who don't trust, and you don't want them to be able to talk directly with each other. You just want them to be able to send one message: this is the value. Or I'm sorry I wasn't able to provide that. Or dead silence, which are the three possibilities. In this case, the promise is going to, you're creating the deferred promise, and then we're going to send a then message and say, whenever this promise is fulfilled, please log the value to the console. And if there's an error anywhere down the line that isn't handled, the done function makes sure that the user gets to see it. This is a program that, building on that program, this is what happens if you are to resolve it with a fulfillment. In this case, I'm resolving my promise with hello world. And then what will happen here is that the then message is going, on line 3, the then cart is going to be sent to the switch, and it's going to stop there, waiting for a value to be available. And then we proceed to line the significant line number 4, and we resolve it, it lays the tracks off to hello world in the fulfillment state, and then in another event, what will happen is that the cart will proceed up to the fulfilled tracks and get called, and its callback will get called with the value. In this case, it will be logging hello world to the console. But from now until forever, the gate is open and it will lead to the fulfilled state. So if you send another then callback, another then message to this promise, it's going to roll up the tracks again immediately in the next turn and log hello world. Has anybody ever listened for document ready? Yeah? What is special about listening for document ready?
Tom's ready.
The DOM content ready event.
You ensure that the other DOMs can get work.
Yeah, it's going to fire. This event is going to fire when the entire document is loaded. jQuery had a bug. Isn't that shocking? for a long time, that was solved, okay, maybe 5 years ago. It doesn't have as many bugs now. But one bug it did have was that if you used script injection to load jQuery, you would never receive the document ready event because it's already happened. So they had to solve this problem by using 2 paths. They have one code path that's setting up the event listener so that they do receive it when it does happen. And then the other code path is looking at the document.ready state variable, checking to see if it's the right magic number, and then firing your event anyway, right now, because it's already ready. And this should be exposed as a promise. For all I know, it might already be exposed as a promise since jQuery has promises now. But the trick is like this, is a promise, that it has this state from the past that you're interested in. It's not an event. You're not listening for an event. You're listening to whether it's ready or not, which may have occurred already. So a promise, if you had a document.promise, it would be a deferred promise. There would be an event handler already set up for you at the beginning of the program that would catch that case and then resolve the promise so that you can proceed with the assumption that your document's ready. And you would be able to send carts, these then carts, to that promise before the document's ready, after the document's ready. Your program will be exactly the same. Not to belabor the point, the exact opposite thing happens if you reject the promise. Rejection is like throwing an error. If the deferred if you call reject with a new error, and by the way, like errors, you can throw strings. You should throw errors because stack traces are useful. Same with promises. It's just like throwing it. You can reject with an error, and then what will happen is that your cart will be stuck at the gate, and then it'll be rejected, and the tracks will be built to the rejected state, and in the next turn, it will proceed to that state. The error back will be taken from the then cart, and then called with the error. It's not going to log goodbye cruel world. It's going to log the error object. Yeah. So that's interesting in 2 dimensions. The railroad track metaphor goes so far because in the plane of state, which is just 2-dimensional XY axis, you can move to fulfilled states, you can move to reject states, and generally like that. There is another dimension which is deferral, which is this 3rd dimension. If you take a promise and resolve it, instead of with a fulfilled value or a rejection error, you can resolve it with another promise. This is like, suppose that you are making a cake and you send off your friend to go off and get milk, and you get so you send them off to get milk, and they give you a promise that they're going to give you some milk. If your friend is trustworthy, he will arrive later with milk, or at least reason why he couldn't get it, and hopefully in a timely fashion. And then you're like, okay, I have one of the things I need to make a cake. I also need eggs. So can you go get that for me? And then, so you've already returned a promise to somebody else, saying, yeah, I'm going to get you I'm going to bake you a cake. You will have a cake. Just wait for a bit, and I will get back to you once I've got the milk, right? And then you're up a creek because you've got the milk, but you don't have the cake. So the next step is that you get another promise for the eggs, or vegan substitute. And then you take that promise and you resolve the promise that you already gave someone else with that promise. And that is how you buy time, by resolving with other promises. You can do this any number of times. These promises, what will happen is that the promise that you gave someone else will become the promise that you give when you return that from one of the handlers. And you can do this any number of times, and then ultimately, if that promise becomes fulfilled, all of the promises that became that promise will be fulfilled. All of the promises that were rejected will become rejected. And as such, if you imagine this as a three-dimensional railroad, instead of your carts proceeding directly to the fulfilled state, they will be lifted up to the big promise that they become, and then moved into a fulfilled state. Why am I gesticulating? I drew a picture. All of the promises all the carts that arrive in any state will effectively have arrived at all of the states that they shadow in that third dimension. This is just one of the many ways to visualize promises. This is a Petri net, which is part of, in the 90s it became part of the Uniform Model, UML, that's right, that's the Java thing. It really effectively shows these transitions through state space in 3 dimensions, which is nice. I'm going to, for the purpose of explaining how then works, ignore the third dimension. Just imagine that at any time you can defer if you need more time, and it will just be projected into this third dimension. The 2 dimensions of fulfillment and rejection will always be the same. So this is a code example that illustrates what happens when a promise is resolved to another promise. So we're creating a promise for Alice using q.defer, so we have a promise resolver pair, and then we're sending a then cart to Alice. So if you can visualize this, we have our switch for Alice, and the cart with a then cart proceeds and then stops at the gate because it has not yet been resolved. It continues to not be resolved for quite some time. We then create another promise for Bob. Why do we persist in calling these things Alice, Bob, Charlie? Anybody read cryptography papers? They're obsessed with these guys. Why not foobar and Baz, right? So you create a Bob promise, and then you send a then cart to it. So now you have 2 separate promises, 2 sets of tracks, and there's 1 cart waiting for Bob and 1 cart waiting for Alice with these then messages. You then do something tricky. You resolve Alice with Bob, making them equivalent, superimposed on each other in the third dimension, which means that all of the carts that were waiting for Alice, checking to make sure I'm not saying something wrong. Yes, all of the carts that were queued up on Alice are now going to proceed up into the third dimension to the waiting queue for Bob. So now 2 carts are waiting for Bob to resolve, one of which thinks that it's waiting for Alice and one of which thinks that it's waiting for Bob. You then resolve Bob. Alice gets, Alice's cart goes to the fulfilled state and gets logs 10. Bob proceeds to the fulfilled state and logs 10. Which takes us to what makes promises like Legos. They stack. And they stack using the then method. So the then method is like a try-catch, except that you don't need the try. You might not need the try and you might not need the catch. You can pick which one you need. The callback is going to be your how you're going to handle the success from your promise, and then how you're going to handle an error. Within each of these handlers, I lied, they're not callbacks, they are handlers, which have one important distinction. They can return things. With a callback, you can only go forward. With a promise handler, you can return something, and you can return a value, you can throw an error, or you can return a promise if you need to buy time. And you can do this either in the callback or the errorback, or the fulfilled handler, or the error handler, or rejection handler, if you will. They're identical in interface because the guarantee with a promise, and this is a guarantee with promises and not a guarantee with callbacks, is that only one of these functions will ever be called. It only makes sense that one of these functions will be called. You're either going to fulfill or you're going to reject. If it wouldn't make sense to fulfill more than once, it wouldn't make sense to reject more than once, it wouldn't make sense to mix and match. One of these will be called. And its responsibility will be to resolve a deferred promise, output promise, which is what then returns, which makes these things chainable in two different ways. You can chain promises either by chaining a then on the output promise, or you can return another promise from within the handler. Going back to our railroad analogy, this is what it looks like. You send a then cart to the deferred input promise state, right here, gate number 1. And then, supposing that that promise is fulfilled, you will proceed into the fulfillment handler. The fulfillment handler is this gate right here. And if the promise that is fulfilled, if the fulfillment handler returns another promise, you're going to go up in the third dimension. If it returns a fulfilled value, you're going to proceed to the fulfilled state of the output promise with the value you returned. If you instead throw an error while attempting to resolve the output promise using the input value, it will take you to the rejected state with that reason. If you if you instead go from the initial state and are rejected, you will have an opportunity to recover from that error, just like a catch block in a try-catch. So in a try-catch, you can proceed as if nothing wrong happened and smooth things over, or you can throw the error you got, or you can create a new error, or you can annotate the error you already got with more information about why or what failed. All of those things can be done in your errorback, and then you can either throw that error, throw a new error, or fulfill with a value, signaling that you have recovered. You can also, of course, punt to a future turn if you need more information, which makes it possible to recover from errors using a variety of techniques. So, recap. What the then method allows you to do is to do all of the things you can do synchronously with a try-catch. You can pass fulfillment through. You succeed, the output succeeds. You can take something from the input, transform it, and create output. You can take an error, recover from it, and proceed. You can take an error, realize there's nothing you can do about it, and proceed with the error. Or any number of these scenarios where data is flowing from the input to the output, managed by the input and output fulfillment and rejected handlers. So, noteworthy, you can omit either of the callbacks. You can omit the fulfillment handler, you can omit the rejection handler, you can omit both. If you omit both, it doesn't mean much, because it's just saying the input's the output. Whatever. But if you omit a fulfillment handler, what it's going to assume is that the value from the input should proceed to the output. Which is handy in the case where you do provide an error handler and aren't interested in the case of success. If you have an error, if you omit the error handler and are just interested in composing the input with some more data or weighting or anything like that, then the error handler, the implied error handler just forwards any errors that it receives from the input. So these top two examples are equivalent. If you omit the error handler, it's just like a rejection handler that takes the error and rethrows it. And then the bottom three are also equivalent. If you omit the fulfillment handler, it'll it's the other way around. The top one is passing forward a rejection, the bottom one is passing through fulfillment. And the last one is just a convenience that some libraries provide, promise.catch or promise.fail, which allow you to just specify the error back for our then method. Otherwise, it's exactly the same. Any questions so far? I realize that these slides have gone long.
Is throwing the error and the rejection, is that new? Or have you always been able to do that?
It depends on what library you're using. Q has always, well, not always. It's been able to do it for 3 years. jQuery still philosophically thinks that if you want an asynchronous error, you best create an asynchronous error and return it. All this implicit handling of errors, rightly so. I mean, there is some risk that if you swallow one of these exceptions, that someone might forget to handle it. And then there are other libraries, less noteworthy, that take a third road where if you have not added a rejection handler to a promise by the end of the turn and at the end of the event in which the promise was created, it will assume that you are never going to attach an error handler and propagate the exception from there. I'm not actually going to, I intended to talk about debugging promises in this talk, but I have a lot to say and just ran out of time to write the slides. And I'm going to run out of time today to talk about them. But one of them is that I have an experiment for a promise debugger that adds another panel to the web inspector that shows all promises that are pending. Gives you a stack trace for all of the promises that are pending. Shows you any progress notifications that they've received, like I'm still working on it. Don't worry. And also shows any rejections or errors thrown within the promise system that have not yet been handled. There's always a possibility that somebody's going to add a rejection handler later. They will disappear. So it'll give you a live view of what the state of your program. I have a prototype of it. It's not production ready.
Are you forking the inspector for that, or?
No, I'm running a Chrome extension. It turns out that it's pretty straightforward. Oh, that's harsh. No, it is not pretty straightforward. There are some interesting back-channel communication things that you have to do to make Chrome do your bidding. But thankfully, the guys who wrote the Ember inspector did all that work for me, and I was just able to crib it. So if you need a URL for a project that does it, I can give you 2. So this is a practical example. I hope that you got a chance to take a look at it. This is an example of using promises to mediate authentication. The idea here is that you got somebody waiting on you have a program that's running in Node, for example, or it could be in a web browser. This could be powering forms, where you're asynchronously waiting for the username and then asynchronously waiting for the password, and then proceeding to verify that the passwords, that the hash of the password matches the known hash of the password. So first we get the username from the user. The user gives us a promise for their username. And then when we have that username, it's like that situation with making a cake, that we've got one of the ingredients we need, but we don't have the other. We have the username, but we don't have the password. So instead of, and in this case, we have the username, but we still don't have the record for the user from the database. So what we're going to do is take that username and upgrade it into a user record by going off to the database and getting the user for that username, which will return a promise, which we return in our fulfillment handler, which makes it so that the resulting promise becomes the user record from the database promise, which flows through into the next call, into the next then handler. Once we have the user, we ask the user for their password. And because we need the user's user record, at the same time we need their password, instead of doing chaining like I did up here, we're doing nesting. So now I can capture the user record in this parent closure, and then the user's supposed password in the nested closure, and then I compute the hash, compare them, throw an error if they were lying. Is that clear? Does anybody want to look at this one? This is a little dense. Good to go.
It's supposed to be a resolution when successful. That's what Kris.
Resolution on success. The resolution, so this is, you're talking about get password, right?
Yeah, I just don't see it a resolve.
That's the thing, is that your get password is going to do that. Get password is returning a promise. It is creating a deferred promise and returning it to you. So the function you call has the resolver and the promise, gives you the promise, keeps the resolver, and then calls the resolver when the user finishes typing their password. Does that make sense? All right. Yeah, in jQuery, noteworthy, the promise and the resolver are one and the same. Because jQuery didn't think about, well, and probably doesn't need to think about the case where jQuery is going to be used where multiple suspicious programs are running together. But that's a bad assumption for an API designer. As an API designer, you want to make the decision that enables people to use their API in a secure situation, not the one that disables them from ever using their code in a secure situation. And this happens, and because people make this assumption all the time, it is therefore very